So it's my third talk of the day, so I start to be a little bit tired. But I will try to make it. So in this talk, it's going to be completely different from the other talk. I'm not going to speak about reactive or data management. I'm going to speak about security. How cool can that be? And about the specification that has been proposed and integrated into the microprofile, that is about JWT. So this presentation has not been prepared by me, but by Scott Stark and Heiko Braun. And I don't know, I lost something, so I'm here. No, it's really cool. You will see. So the first thing we need to learn is how do we pronounce JWT. And if you look at the spec, it's at the beginning of the spec. They say it needs to be pronounced JWT. So we need to pronounce JWT. So I'm going to present Microprofile JWT. Okay, why not? It's a suggestive pronunciation, so you can pronounce it as you want, but yeah, it's kind of fun. What is also interesting here is that this spec, so JWT JWT, is based on two other specs, which are JSON web signatures and JSON web encryption. And we will see that both are not completely equivalent. So JWT is a spec, that, so it's an RFC. And the idea behind JWT is to securely transmit objects from one point to another point. And how do we do that? Well, there is two ways to do this. First, it's going to be JSON. Okay, fine. And we can send signed object where we receive it, we can verify that it's the right one, there is no tainting and so on. Or we can send encrypted tokens where, in addition to integrity, we can also be sure that we are the only one where we are allowed to read it. So in this presentation and in Microprofile, we are more interested by this second part. So how does that work? Well, it's actually quite simple, and that's why it's so popular. We take JSON, whatever it is inside, so you have a token, so you can write whatever you want inside. It's a quite compact format. How they do that, we will see. It's actually encrypted. And this compact format is URL safe. So you can actually pass the token as a query parameter, or even as a pass parameter. It's kind of weird to pass a token as a pass parameter, but it will work. You can also pass as inside the payload, okay, no problem. But most of the time, you pass that as an HTTP header using inside the authorization header of your HTTP requests. When you do that, how it works? First, you need to log in. It's all about security. So you log in as Clément, for example, and you will get a JWT token back. Fine. Then you cache it. You can cache it using local storage or using a cookie. Local storage is recommended. Every time you want to access a secret resources, you are going to pass this token using one of the way I've described. So query parameters, authorization headers, or in the payload. Well, if it's a get, cannot be the payload. So one of the two. So you access here, and here your service is able to verify that this request has been emitted by Clément. And that's the key thing, is that this verification does not need anything. If it's agreed and if everything is fine, it can send the serve request. So everything that is inside this token allows the microservice to check that the token is valid. It means that this service won't call the issuer service anymore. It's very important in terms of scalability, because if you get millions of requests and you will need every time to delegate to something else to verify if the token is valid or not, you are going to kill this other guy you are calling. So, and you don't want that. So the fact that the token contains everything, so this one can verify it, it's very important. So how does that work? Well, I say it does not delegate, but there is one access, at least one. Because the token is either signed or encrypted. And in both cases, you need a key. It can be a public key, it can be a shared key. Let's take a shared key for now. So when you log in using your SSO. You know, you can log in, then you get your JWT token back, But when this microservice started, it retrieves the shared key from the SSO. So I say when it started, or it can be at deployment time. There is several ways to do that, but generally when it starts, it's a good moment to do it. So then you get the shared key here, you receive a token and can verify it. How do we verify it? It's just cryptographic hash. So we just look and check if it's valid or not. So in that, as the JSON content can be extensible, it's not only your username that you can pass. You can pass a lot of different things, and you can pass authorization and role metadata. For example, maybe Clément is also admin. He's part of the admin group. Don't do that, never. But maybe, and then in that case, I pass inside the role metadata the groups in where the user is, and then I can do role-based management inside my microservice. So your token is going to be structured in 3 parts using period between the parts. We have the headers, we have the payloads, and we have the signatures. And all of three are going to be encrypted using base 64, and that's why the result is URL safe. So it can be passed inside URL and query parameters. So let's start by the header. The headers contain this, just taking that into JWT token, and the algorithm that is used to verify or to unencrypt your token. Here it uses hashmark with SHA-256, so it just enforces integrity. Then you have the payload. The payload contains claims. That's how they use them. They define in the spec a couple of them. The first one is ISS, which is the issuer URI. Okay. We have the expiration date, because the token expired. And we have the YAT, issued at, so it's when the token has been created. And the sub, which is subject. So how do they end up with subject? I don't know. So, but it's a username. Okay. You can also add a couple of things like user principal name, for example, my email address, and the groups like admin, users, and so on. This is custom, and this is part of the spec. And as I always wanted to have a wall of encrypted data on the slide, I did that. So this is the result. We have the header, we have the payload, and we have the signature. The signature verifying the integrity of the rest. Okay, so that was about JWT. So what about Microprofile JWT? Well, when you start using JWT, it's always a little bit tricky. First, you need an SSO service, but I believe you have one. Then it returns the token, but you need to verify it. So you need to extract it from the HTTP request, and you need to verify it. And verification is about cryptography, and you don't want to do cryptography because it's complicated. It's a lot of math, and the beauty of pointer algebra. You don't want to do that. Fortunately, it's what Microprofile JWT is doing for you. And in addition to that, it's going to inject all the claims or the claims you're interested in inside your JAX-RS endpoint. So it's doing three things. It's going to extend the token. We will see a few claims that they added. It will automatically verify the token and return the right response if it's not allowed, and also inject the claims from the token. So in terms of extension of the header, it's not much. They have added content type, which is JWT, and the algorithm has to be RSA with SHA-256. So what's the difference? This one, hashmark using SHA-256, is a symmetric algorithm. That means that a single key is used to compute the hash of your payload and headers and to verify it. So it works great. It's really fast. It's probably the fastest. The only issue is you have one share secret, and if it gets tainted or if you have a leak, you're screwed, because they can encrypt and make believe that they are you. While with RSA and SHA-256, then it has asymmetric algorithm. It's a public key pair, and then you distribute only the public key and not the private key. So the microservice verifying the token cannot impersonate the issuer service because it's unable to encrypt. It can just read it. That's why the specification recommend, well, at least mandate RSA 256. In terms of payload, the Microprofile JWT has defined two custom claims. One is UPN, user principal name, which is actually the name that is going to be returned from Java security principle, which is the main user representation in Java. We are going to see that. If not there, the spec says that you need to fall back to either the OpenID Connect preferred username or the JWT sub, but it's more precise. So typically your sub can be just my ID, while my UPN can be my email address, so much more precise. Groups is a list of groups in which I'm in. So typically, am I an admin, I'm a silver or platinum member, and such kind of things. So you are a microservice, a microprofile microservice. You are using an implementation of Microprofile JWT. You receive an HTTP request. So you have a JAX-RS endpoint, and this request is going to be automatically checked if it contains a token. The token is going to be automatically validated for you. So what does it validate? It validates the signature. Okay, fine. That's the first thing you need to do. Once you can read it, it will validate the ISS claim. So to be sure that the token has been generated by your issuer service, so your SSO, and will also check for the expiration of the token. And if any of these checks fail, then I can't remember, I think in the forbidden or unauthorized HTTP response, unauthorized HTTP response is returned automatically to the client. So you don't have to take care of this. It's going to do that for you. It's quite some code. So, but to do that, we need to configure two things. Where is my public key, and what's the name of my issuer service that I want to verify? And you do that using these properties that come from Microprofile config. So you just set them, typically as a config map, environment variable, or one of the supported way, and it will just pick them automatically. You may wonder about these queues. We are going to see that. Once you have received the token and verified it, and the JAX-RS endpoint is going to be called, it may need to read who you are. What's your username? What's the username attached to this request, and on which group you are? And how it works is that it's going to inject a JSON web token, which is a type defined by the specification. And from this class, you will have access to all the standard and custom claims. So it extends Java security principle. If you don't know this interface, it's just contain get username, but yeah, it's defined by Java. And you can access the standard claim using getter and custom claim using a specific getter. So let's look at some code. This is my JAX-RS endpoint. And see, I can inject the JSON web token like this. Obviously, if the request is not authenticated, it will be rejected because I have the @deny or JAX annotation. If the request comes, but the token is invalid, it won't be called either. It will be rejected. So you don't need to handle that anymore. Then you can, if you really love having the JSON things directly, you can retrieve the token using these claims here. Here you have claim value of string, raw token, and here you have directly the result. So it's a pseudo claim, the raw token. And you retrieve it as string and not as JSON, as I said. Okay. You can have access directly to any of the claims from your token, like the issuer service, like the expiration date, and like the full name, and your custom claim. So I don't really understand why you will need the issuer and expiration name, except for logging, but well, it's supported. But these ones are actually interesting. First, as it's extensible, and the token is extensible, the data you're looking for may not be there, because you know it's all mobile client and it doesn't pass it, or the issuer service has changed or something like that. So you can immediately use an optional object from Java for all the claims that may not be there. Then you can check inside your endpoint, your method endpoint, whether or not it was present. And you can even use almost functional programming. If it's a custom claim, you can just access it like that, either as an optional or directly as a Java EE7 JSON object, or whatever object you want. So that was for the injection. It also integrates with the containers API from your Microprofile environment. So typically, it's going to be integrated with a security context. So in a JAX-RS endpoint, you can inject the security context, and the security context has this method, getUserPrincipal, that returns a JSON web token that we had before. And then you can access all the claims and all the other ones. Not very interesting because you could have injected it directly. But it has this method here, isUserInRole. And that's way more interesting because you can check that the user that is there belongs to one of the role you want. So how it's mapped, it's a groups claim that is defined by Microprofile JWT, contains the name of the role you are looking here. So you can implement airbag, so role-based access, really quickly. So if we look at this, yes. So that's the full code, but let's dive into it. So the first thing is that you can immediately say add role allowed here, directly on your JAX-RS endpoint, and it will only accept requests from users where the token contains a tester role in the groups from your token. And it also supports multi roles, so you can say tester, admin, and so on. Then you can inject the security context, as we do here, and you can just retrieve the user principal, and as I say, the user principal is JSON web token, and JSON web token implement Java security principal. So you have a principal object. Your principal object, well, you can use it like this. We're not going to see that. Obviously, as I said, because we have this isUser role, you can implement custom airbag here. So for example, I know it's a tester because we had this annotation first. But then I want to do different things if it's an admin tester or if it's not an admin tester. For example, if it's not an admin tester, I'm returning to provision, which is stupid because I could have just added that there, but yeah, that's just an example. And it returns a 403. And if it's an admin tester, then I can just return the get name as a text. Get name, so user get name, user being the principal, is going to fall back to the UPN claim, so user principal name, which, if not present, will fall back to the user preferred name, preferred username, and sub claims from the token. JWT has been very, very popular in the past few years. One, because it's based on JSON, and almost every language today can do JSON, even COBOL. Yeah, there is a JSON COBOL library. So the thing is, it's also heavily used in microservices. And why? Because when you have microservices, you want to forward your token to all the requests, so you don't have only the first endpoint or your first microservices that will retrieve the token, but you want to pass this token to all the subsequent requests. So that's very nice because you can do it. It's just a header to pass, so that's very cool. But as soon as you do microservices, scalability is one of the first issues you will face. So how does that work here? Imagine that I don't have one client, but thousands of them. They will all connect to your SSO service and all get a different JWT token. This token is stored inside the device as a local storage or cookie or whatever they want. If it's a custom application, they may find a different way to do that. And then all those devices will access the token. One of the cool things is that if you need more token, you can just scale your SSO service. That's it. generally they scale pretty well, and they are made for. If you take a key clock, it can handle millions of users, so it's not an issue. Because we have only one access here, there is no pressure coming from your microservice to the SSO service. If we will need access to the SSO service and we will have hundreds of microservices, this one will have been very tricky to scale. But no, we don't need that. So how does that work? Well, each client is going to get a JWT token, fine, and this JWT token can be used for a couple of requests, like this, and when it's expired, then it will go back to SSO and so on. So now, if you really have scalability issues, there is a trade-off you can do. You can extend the expiration date. So you configure your SSO and say, okay, instead of being valid for 1 week, it's going to be valid for 1 month. It's fine. However, you cannot revoke access for 1 month. Kind of tricky. But, and if you want to revoke access or having control on that, you will reduce the expiration date to, oh, it's not going to be 1 week, it's going to be 1 hour. And then you are doing something very, very bad in terms of UI, that you get the logging screen every hour. But a lot of systems are done like that. So depending how much control you want on the revocation, you will choose the right expiration period for you. But don't forget that until it's expired, you cannot revoke access. Well, this is not completely true if we introduce key rotations. Right now, as I say, well, there is one key. It's a public key, but there is one. But what about adding more than one? Because when we have one, all the tokens that I'm emitting are always signed with the same key. But I may do rotations. I may decide that this key is invalid. That's what JSON web key set allows us to do. So our SSO won't be configured with one key, but a set of keys, and will expose a JSON web key set endpoint. So, and that way we can go to the SSO service and say, okay, revoke that specific key. Or every we do a key rotation, so every login will get another key. So that works well, but to integrate that in your microservice, if it will not be automated by Microprofile JWT, you will need to retrieve this key set, and this key set can change, so periodically retrieve the key set. That can be quite complicated actually. So fortunately, and that's why we have this public key.location property, you pass the URL of the key set, and it's going to do that for you. The keys are retrieved at startup, and upon verification failure, this second part is not true because it's an attack vector, actually, we'll explain it. So it's upon verification failures with some rate limiting factor. So how does that work? Well, when the microservice starts, it'll retrieve the JWT key sets and will store them inside the microservice. It's all made for you. And when a token arrives, the token has been extended with the ID of the key. So it will check the ID of the key, find the right key, and validate the token using this key. If it failed, that means two things. Either the guy is invalid, or the access has been revoked, and so on, or the key has been removed. So for this reason, when it failed, it should retrieve the key set again. And here is the attack vector, and that's why we should not do that without a rate limiter. Because imagine someone realizes this. What he will do? He will take a token, taint it to be sure they trigger a failure, verification failure, and emit millions of requests. So what he will do is that millions of invalid requests will arrive here. They will all fail the verification, and if you reload the key set on each failure, it will emit millions of requests on your SSO service, and then you have a scalability issue. So a lot of clients, of JWT clients, are doing this. Don't, because that's an attack vector, and you can kill your SSO because of this. Well, you can kill your microservice because of this too, but killing the SSO is kind of hard. Well, it's not cool. So on signing failure with a rate limiter, we will reload the JWKS key set, rate limiter, time period, or whatever. So how does it look like? The JWKS file is like this. So you have a set of keys, so it's a JSON array, and that's one key, RS-256. So right, that's all right for Microprofile JWT. Key type RSA, use for signature, it's always this. Well, that's the key. It's base64 encoded, that's what JSON mandates for binaries, and that's your key ID here. So you have this is already managed by most of the SSO, so you don't care about that. And then inside the token, you have the key ID here as a key. So the headers are extended, and Microprofile will retrieve that, check that there is the key ID, and say, oh, you have invalidated against this key ID, and use the right key and do all the logic for you. Actually, yeah, there is a couple key ID and ISS that are checked. Conclusion. Okay, so Microprofile JWT in one single slide. It will let you authenticate your request using JWT or JWT very easily because you don't have to do anything. You just configure two properties, the location and the issuer ID, and you're done. It's going to validate the HTTP request, verify them, and inject the claims, and even custom claims. Fortunately, there is a couple of things that are still missing, is that because Microprofile JWT has extended the JWT token format with two claims, you need to have your SSO server aware of this one. So most of them allow configuration and works very well. Some of them still need a bit of work and will align very quickly. The Microprofile implementation, so how does that work? You start your Microprofile microservices with a Microprofile JWT implementations coming from any of the Microprofile implementations. So you can take Wildflower Swarm, you can take OpenLiberty, the one Payara Micro, or any of the other one. You just put that in your class path and it will all work magically. We'll verify them, manage a key, reload the key if needed, and inject all the claims. So you don't have to manage that. And that's all I have. Thank you very much. I will try to do my best to answer your question. But yeah, I didn't participate to writing the spec. I wrote some other spec. I just reviewed that one, so but I may be able to answer your questions.